All right, welcome back. Today we're going to be doing graded potentials and summation. So let's begin. What's graded potential? My definition is membrane potential or membrane voltage changes across the membrane. What the hell does that mean? I bet that's I bet that's exactly what you're asking right now. Because when I first learned about this, I said the exact same thing. Well, I think it helps with a picture because the definition doesn't make any sense. You Google this, it won't make any sense. A picture helps. So we have a neurotransmitter, it binding to the receptor, and now we got sodium coming in. When sodium comes in, the voltage goes up. Notice on the neuron, it's different colors throughout the membrane. What this is signifying is the voltage is different across distances, across the membrane. Nearly exactly what the definition says. So around here, maybe it's around 40 millivolts. And as we go further out, let's say 20 millivolts, and in here, maybe negative 30 millivolts, and then, over here is like negative 60 millivolts, basically nothing. So you can see that as distance, the higher distance, or the further the distance, the lower the membrane, the lower the potential is. Why does this happen? Well, one reason is ions leak out. So we are having sodium come into the cells. There's sodium here. Well, there's something called leak channels. And leak channels are essential because we don't want the sodium to stay in forever. So some sodium are just going to passively leave. And that was one reason we get a lower voltage. It's because sodium is positively charged, and when something positive leaves the cell, the voltage goes down. A second thing is the resistance of the cytoplasm. So the cytoplasm on the neuron has some kind of resistance to it. And this is a physics thing. You probably won't be asked this, but there's a chance. There's something called Ohm's law if you've not learned about it yet. What Ohm's law states is the current, which is I, equals the voltage, which is V, divided by R, which is the resistance. When you redo this equation, rewrite it, we can rewrite it as the voltage is equal to the current divided by the resistance. Some fun facts is the current, not fun facts, but facts. The current is measured in amperes. The voltage is volts, and resistance is measured in ohms, stylized as omega. Notice in this equation, resistance is in the denominator. So the higher the resistance goes, the lower the voltage we will have. Exactly like number 2 states, basically, is the resistance to cytoplasm causes voltage drop. So you can imagine, why is this a problem? Why are we learning about this? Well, imagine the axon hillock is right here, okay? And the action potential will go down this way, down the axon. Well, if we're at negative 60 millivolts here, we are not at threshold. Imagine if the threshold's at, negative 40 millivolts. We're not there yet. We need to reach negative 40 millivolts to actually have an action potential form. So we're not going to have one. The voltage is too low. So what does the cell, what does our body do to combat this? Well, that's where summation comes in. There are two kinds of summation. So I plagiarized these pictures from my textbook because I think they did a good job for once. So yeah, I think this is the best way. So so the first thing is temporal summation. You have two forms. You have temporal. Think about temporal summation as time. What this is saying is we get our first stimulus, but the first stimulus is not enough to create an action potential. So a second stimulus is going to come and hit the exact same location, but literally moments later. Like I'm talking about milliseconds later. And this is enough to generate an action potential. Let me give you an example. So say you're on an airplane. You're going from Los Angeles to London. Your takeoff, you're in the sky. But your pilot decides to have a little fun in the air. He's like, you know what? Let me turn off one of the engines. that plane ain't gonna get to London, okay, on one engine. So, miraculously, your pilot decides to be a genius and turn on the second engine. Now it's gonna get to London. So that first engine or first stimuli, is not enough to get to your destination. The destination being the actual potential. But a second stimuli, or second stimulus, sorry, grammar, it's enough. And basically it has to be within milliseconds. Now we have spatial summation. Think about spatial as space. What this is saying is you have two stimuli hitting the exact same place at the exact same time. They're not spaced out. Like temporal, they were spaced out by a few milliseconds. Right? The first stimulus to the second stimulus, it was spaced out by a few milliseconds. In spatial, they're at the exact same time. They hit exactly at the same time. So you're basically your pilot, pretend there's no engines running and you're in the sky, and all of a sudden he turns on both engines at the exact same time. Boom, a lot of power. We got that actual potential to go. That's what it's basically saying. I know that example does not make any sense, or it probably does, but that's how it makes sense in my mind, okay? So if it doesn't make sense for you, I don't know, just put it in the comments, I'll come up with something else. But yeah. Anyways, I hope this was beneficial, and please like and subscribe. I love you guys. Keep on the support. I have now like 39 subscribers or 37 subscribers, whatever. Love you guys. That's amazing. I'm going to keep doing this forever and ever and ever and ever. And yeah. See you guys later.